Hello, welcome. In this lecture, we're going to apply the concept of vector to construct the equations of lines and planes in 3 dimensions. Let's begin our discussion with line. A line in 3-dimensional space is determined when we know a point P sub 0 with fixed coordinates x sub 0, y sub 0, and z sub 0 on L, and the direction of the line L. In 3 dimensions, the direction of a line is conveniently described by a vector. We let V be a vector parallel to L. Let P with coordinates x, y, z be an arbitrary point on L. And R sub 0 and R be the position vectors of the points P sub 0 and P, respectively. If A is the vector with the representation P sub 0 P, as in figure, then the triangle law for vector addition gives R equals R sub 0 plus A. But since the vectors A and V are parallel, there is a scalar t such that A equals t times V. So the vector A is some scalar multiple of the vector V. Thus, the equation R equals R sub 0 plus A would become equation 1, where A is replaced by the vector t times V. If V is the vector with components a, b, c, then the equation 1 can be written in terms of components as follows. R is the vector with components x, y, z, since it is the position vector of the point with coordinates x, y, z. And R sub 0 is the vector with components x sub 0, y sub 0, z sub 0, since it is the position vector of the point with coordinates x sub 0, y sub 0, and z sub 0. And V is replaced by the vector with components a, b, c. Now, if we add the vectors in the right-hand side of the equation, the first component of the vector would be x sub 0 plus a times t. Similarly, the second component would be y sub 0 plus b times t, and z sub 0 plus c times t would be the third component. Now, by equating the components of the vectors, we obtain x equals x sub 0 plus at, y equals y sub 0 plus bt, and similarly z equals z sub 0 plus ct. These 3 equations are called the parametric equations of the straight line L. Now, if we eliminate the parameter t from the equation 2 by Considering A, B, and C are non-zero, then we get the equation 3, which is called the symmetric equations of the straight line L. If, for example, A equals 0, then from this equation, we would obtain x minus x sub 0 equals y minus y sub 0 over b equals z minus z sub 0 over c, since we can divide by 0 there. So this equation would not work then. The components a, b, and c of the vector v are generally called direction numbers of the straight line L. Let's have a look at an example. We need to find the vector equation and the parametric and symmetric equations for the line that passes through the point with coordinates 5, 1, 3 and is parallel to the vector I plus 4j minus 2k. In the second question, we also need to find two other points on that line other than the point with coordinates 5, 1, 3. Here, the coordinates of the fixed point x sub 0, y sub 0, z sub 0 are 5, 1, 3 respectively. And the vector is I plus 4j minus 2k. Therefore, the parametric equations given by x equals x sub 0 plus at, y equals y sub 0 plus bt, and z equals z sub 0 plus ct, where a is the number 1, b is 4, and c is negative 2, we obtain these equations, the parametric equations of the straight line. Similarly, the symmetric equations given by the equation 3 are these three equations obtained by eliminating the parameter t from these three equations. Now in B, we let t equals 1, then the parametric equations give x equals 6, y equals 5, and if we substitute t1 here, we get z equals 1. So the point Q with coordinates 6, 5, 1 is a point on the line. Similarly, if we set t equals negative 1, the parametric equations give x equals 4, y equals negative 3, and z equals 5. So R with coordinates 5, 4, negative 3, 5 is another point on the line. For every real number t, we have a point on the straight line. We just generated 2 points other than the point given in the question. And this figure illustrates the work we've done. So we obtained the equations, the parametric and symmetric equations of this straight line, which is passing through the point P with coordinates 5, 1, 3. And the line is parallel to the vector I plus 4j minus 2k. And in the part B, we also generated 2 points with coordinates 6, 5, 1, obtained by setting the parameter value 1, and the point R obtained by setting the parameter value -1. And the point P can be rediscovered by setting the parameter value T equals 0.